Good morning, class. So today we're looking at the introduction to algebra. For homework you had exercise 7. Okay. So today we're looking at unit 6, which is formula. Okay. Let's check if I'm on the right track here. Okay. So these are the examples for exercise 8. And exercise 8 is on page 22. Okay. However, the example is on page 21. Okay. Let's go. So formula. We are given K, which is 2. If K is 2, M is 4. If K is 3, M is 5. When K is 4, M is 6. When K is 5, M is 7. When K is 6, M is 8. When K is 7, M is 9. If K was 10, what would M have been? 12. If K was 35, what would M be? 37. You all understand? Who doesn't understand? You all understand? Okay. What do you notice? You are plusing 2. So if M was X, if K was X, what would M have been? If K was X, what would M have been? 2X. Now if you're saying 2X, what is between 2 and X? Times. Are we multiplying here? No. What are we doing? We're adding. So in other words, this would have been X plus, if I had to extend it to that. You guys understand? But now, we actually have a K. So what is M going to be equal to? K plus, does it make sense? So if you set up a formula, then that would simply be M is equal to K plus 2. You see that? So if K is 2, M is 4. If K is 3, M is 5. Can you see that, people? If K is 35, M is 37. Does it make sense? So let's read what they say. In words, the above table says every M value is 2 more than the K value. Okay. The formula M is equal to K plus 2. And this is what we call a formula. Okay. Or an equation was. Alright. So now we're looking at plug this in here. Now the formula is your mathematical notation for that sum in words. Can you see that? The sum in words was this here. Can you see that? The sum in words was that. Okay? This is what we call mathematical notation. So that sum in words we translated into mathematical notation. And that mathematical notation is called a formula. You guys understand? Okay. Now we look at example 1, and example 1 is also on page 21. Let's look at the first one. You got X is 3, then Y is 9. If X is 4, Y is 16. If X is 5, Y is 25. If X is 6, Y is 36. If X is 7, Y is 49. What if X was 9? Y is 81. If x is 15, y is 30? Or is that too big for you? 10. 100. 15 would have been 15 times 15, which is 225. So how do I move from one term to the next? It's going to be, it's a number squared, not so. So it's x value squared. Whatever the x value is. So if x, if the first number is x, then what's the second number? X squared. You guys see that? So my formula would be y is equal to x squared. Does that make sense, people? Who's confused? You all understand? No? Am I moving too slow? Huh? Okay. Let's move on to the next one. Here's another one. Okay. One of these formulas has, I think it's in the worksheet. The homework that one of the numbers doesn't add up to one. But we'll highlight that to you when I get to that table. Okay, here we got A. If A is 3, B is 7. So think about this now. No? If A is 3, B is 7. If A is 5, B is 11. When A is 6, B is 30. So what happens to this number actually? What happens to 3 to get 7? Times 2 plus 1. Not so? The next one was 5 times 2 plus 1. The next one is 6 times 2 plus 1. The next one is 8 times 2 plus 1. The next one is 9 times 2 plus 1. If I put the 12 here, what would the answer be? 12 times 2 plus 1, which is? You all agree with that? So if I had done the same here, I had to actually do that here. You could have seen it. What's happening here? It's 3 squared here, 4 squared, 5 squared, 6 squared, 7 squared. So that is how I get x squared. Can you see that, people? Well, look at the first one again. Sorry, I'm going back now. Well, look here now. This should have been 2 plus 2. The next one would have been 3 plus 2, 4 plus 2, 5 plus 2. Can you see that? So this number changes all the time. So this is your variable. It variates. That's how I get that k plus 2 or x plus 2. Does it make sense? So here, that's how I got x was squared, x squared. Okay. So what will your formula be here? B is equal to? That is your variable. It variates. It changes. That's going to give you A times 2 plus 1. Or 2A plus 1. Can I say it's going to be 3A? No. Why? Unlike terms. You understand why is it important to understand when it's like and unlike? Okay? Any confusion at this point? Okay, just throw a spanner in the works here. What would, if I chose M to be, that's not part of the sum, eh? If I chose M is equal to 80, for this formula. If M was 80, then what would K be? Sorry? 78. Why? So I'm working in reverse now. Not so? That would have been 78. Let's look here. What if I chose K to be, sorry, Y? If I said Y is equal to 121, then what is X equal to? 11. Why? Because the reverse or the inverse or the opposite of squares is square root. No, the inverse. What is the opposite to addition? Subtraction. What's the opposite to division? Multiplication. Can you see? What's the opposite to multiples? Factors. Can you see? Most of the stuff, if not all the stuff, has opposites. Okay? You guys understand? What if I chose B to be 51? So if B is equal to 51 here, what must A be to get the B value of 51? Minus 1 from 51, you're going to get 50, yes? Divided by 2 is going to give you 25. So your A is going to be. People, you guys understand? Okay. So the formula, the nice thing about formula, you can work two ways. You understand? You can work forward and you can work back. Okay. Whoever's phone that is, please put on silent. Alright, so let's carry on with our lives. Okay, so now we are told to rent a car, a basic fee of 80 Rand is charged. Okay, now this is many years ago. Okay, they don't charge 80 Rand anymore. The phone call cost you alone 80 Rand. Okay, but anyway, that is a discussion for another day. To rent a car, a basic fee of 80 Rand is charged plus 50 cents per kilo. You guys know what the 50 cents is? Yes. That's a 50. A small coin. The half of 1 Rand. To rent a car, a basic fee is 80 Rand is charged plus 50 cents per kilometer. How much will it cost if I travel 100 kilometers? So, if you're traveling 100 kilometers, what would it be? The cost, let's say cost is equal to your 80 Rand plus 100 times 50. But remember, that is in cents and this is in Rand. So when I bring that sum together, or do the calculation, it must be in the same SI unit. Okay, it must both be in cents or both must be in rands. Okay, so how many rands is the 50 cents? 0,5. Wow, not so. So I say 0,5. So it's going to be 80 plus, what is 100 times half? 50. And 80 plus 50 is 130 Rand. You guys understand? What if he covers 300 kilometers? He goes maybe goes for a drive. What if he covers 300 kilometers? What would the calculation then have been? The cost is equal to 80 plus 100. No, 300, sorry, times 0,5, or times off, or times, yeah, times off. You guys understand? So that would be 80 plus 150 equals, that's going to give you 230 Rand. What if we covered 1,000 kilometers, 500 kilometers? It would have been 500. So it will be 80 plus 500 times 0.5, which is equal to 80 plus 250. So going to give you 330 Rand. You understand? So what changes here and what stays the same? The basic fee stays the same. And it stays the same. What do we call that? Something stays the same. Constant. Right? It remains the same. So we got a constant and we have a variable. So that changes. That value changes. Can you see that, people? So now the question in 3.2 says 3.2. How much will it cost if I travel X kilometers? So let's go. Cost is equal to 80 plus X times 0,5. So that can be written as plus 0,5. Can I add it? Why not? You understand? Who doesn't understand? Simple, no? Right. So if you can't see it, what did I do? I used different values to see what changes and what stays the same. Okay? And the thing that changes, which is also called a variable, that I replace with a x or y or a. Okay? Right. Godwin is Godwin a good one? Let's call him Godwin for now. Okay. Godwin earns a basic salary of 500 Rand per week. You guys get 500 Rand when you go out with your friends, no? No. You get more than that? Yes. She says yes, 500 Rand, no? Yes. Yes, she gets 500. Okay. There's my whole month's. That's why myself. You see why myself is. Okay, just joking. Huh? Right, Goodman earns a basic salary of 500 Rand. Okay, so every week he gets 500 Rand. Plus 25 Rand per item that he manufactures. You guys know what manufacturing means? Yes. That he makes. Okay. So he gets 25 Rand per item extra. So if he makes no items, but he comes to work, then how much is he going to get? 500. If he makes one item for the week, how much does he get? 500. 500. If he makes two items for that week, how much does he get? 500. Okay, you guys get the picture, eh? How much does he earn if he manufactures 10 items in a certain week? What do you call this? Where he gets a certain amount of money per item. We call that commission. No? So that gives the person the reason to work harder. Can you see? When somebody earns commission, they try and work harder to sell or to make. Why? So that they will earn more. Okay? So, and this is called the basic, of course. Okay? How much does he earn if he manufactures 10 items in a certain week? So his earnings, let's call this E for now. You can call it whatever you want to call it, okay? So what will the calculation be? 500 plus 25 times 10. Which will give me 500 plus 250, which is 750. Can you see that? What if he makes 20 items? What do the calculators then have been? 500 plus 25 times 20 would have then given me 500, which would then give me 1,000. Not so? What if he made 30 items for the week? So 500 plus 750, which is 1,250. Can you see? The more he makes, the more items he manufactures, the more money he earns or makes. Okay? You guys understand? Alright. So what is changing there, of course, is that value there is changing. Okay? So of course the next question would be, how much does he earn if he manufactures X items in a week? Okay, so then the earnings is equal to 500 plus 25 times, which is the same as 500 plus 25. And what do we call this? Okay, that is unlike terms, yes. But what we call E is equal to a formula. Okay, or an equation. Okay, but it's particularly here, they're referring it as a formula. Do you guys understand? It's number 4. Still easy, no? Maths is going to remain so easy. As long as you ask whatever you don't understand, you clarify. And you're practicing in the meantime as well. No? It will remain so easy. But when you start saying, okay, I don't understand but I'm too scared to ask, or you're not practicing, then you start losing it. Okay? But you guys was practicing a lot, no? The question says, determine the perimeter P of each of the following diagrams in 5.1. People, what type of shape is this? A rectangle. So how do you calculate the perimeter of a rectangle? You're going to say length plus breadth plus length plus breadth. Or you can say 2 length plus 2 breadth. Or you can say 2 times in brackets length and breadth. It's all the same formula. Okay. So I'm going to go with 2 length plus 2 breadth. Or you could have just said, if you didn't know that, your perimeter is the sum of those lengths on the outside. Not so. So it's going to be 4 plus x plus 4 plus. So what do I do now? You look for like terms. And that's the reason why we did like terms. You remember? So we go 4 plus 4 and x plus x. Not so. And what's 4 plus 4? 8 plus 2x. Or you could have written it, if you would have gone with the x first, the 2x plus, both is acceptable. Okay. So in the exam, if you write either or, full marks. Okay. Let's look at the next one. What type of shape is this? What does it look like? A trapezoid, no? Or a trapezium. It looks like, no? It might not be. Okay. But the question was what? It wasn't what is the shape, no? Under what condition will that be a trapezium? If you have one pair of parallel lines. Is the lines given parallel? How do you know? Looks parallel. Okay, so if you look here, and I make this slightly out, small little. Does it look parallel? Does look parallel. But if I look at this here, I actually made it a bit shorter on the one end. Can you see that? Oh, it's actually the same. You make it like it's a bird. Okay, it definitely doesn't look parallel. Okay. This doesn't illustrate what I'm saying. But did you guys measure degrees and all that stuff for this? Okay. So if you make 2 lines and the one line is out by 0.5 degrees, which is very small, the line won't be parallel. It's only when that distance is exactly the same at any given point of that line, which is the perpendicular distance. We'll talk about that when we come to geometry. So we can't just assume it is parallel, okay? Unless it is given parallel or you've proven it to be parallel. But we're still getting there, okay? So if we're looking at the perimeter, what is the perimeter? It's going to be the sum of that on the outside, okay? But yes, it does look like a trapezium. No? So how do we start? Let's start with 5 plus x plus 8 plus x plus 1. You all agree with that? So what do I look for now? Like terms. So 5 is a like term to what? 8 and 1. 5, x and x. So I'm going to write this, the perimeter is equal to, what's x plus x? 2x plus 14. Do you guys understand? Easy, no? Right, let's do one more. Playing along. Oops. What type of shape is this? Huh? You don't know what this is. How many sides does it have? 5. So what is it? A pentagon. But it's a concave pentagon. Why? Because one of the sides is going in. One of the points is going in. Okay. So it's a 5-sided irregular pentagon. What does regular mean? That all the same sizes, no? All the angles and all the sides are the same. Irregular? No. Not all the sides are the same. Not all the angles. Okay. But again, we'll get to that. Alright. So a lot of things I want to tell you before you write your grade 12 final maths paper. No? You're all going to do maths, no? Yeah? Right. Let's go. It's going to be 10 plus A plus B plus A plus. Can you all see that, people? So what do we look for now? Like terms. So you've got A and A. What's A plus A plus A? 3A. 3A. Plus B plus or 3A plus 10 plus B or 10 plus 3A plus B. It's all the same. Do you guys understand? Any confusion? No. So with that you should be able to do exercise 8. Okay, at this point we'll stop the video. On Monday we're going to start a new topic which is indices, which is exponents. Okay? So have a good night this Sunday night. We're going to have some fun. Okay, stop the video at this point.